Well, hello everyone. Well, this was going to be a review time of a piece of equipment that was sent in to me from our friends over at Banggood. And what we have on the bench is the Victor VC3165 high resolution frequency counter. And I've been wanting to get a hold of one of these, but just, because it goes up to over a gigahertz. In fact, it goes up to about 2.4 gigahertz. Now, from time to time, I'll get some 23 centimeter equipment in here and need to test the frequency. And the only frequency counter I had that went to 1.2 gigahertz was a Timmer that never actually worked that good. So our friends at Banggood sent this in to me to have a look at, and we run into a problem. And as you can see, we're feeding 30 megahertz at minus 13.01 dBm into the frequency counter, and channel A is just showing random numbers. Now, I do have this set to, if you go to function, I have it set to 2, so it's on function 2, and I'll confirm it again, and it'll sit there and do its thing, and then it'll start showing random frequencies. Now, the thing is, like I said, this is a high resolution counter. It is not going to automatically show you a frequency, say like one of my other counters, like our leader sitting up here, that would display the frequency just as soon as you hook it to it. The sampling rate is a little slow on this. I have checked channel B, and channel B works great. It goes, from 50 megahertz all the way up to over 2 gigahertz, and it works okay, no problems. Now, our friend Mike did say, well, you already got a frequency counter, we can use the Rigol spectrum analyzer, and he is correct. It works great, but I know not everybody has a spectrum analyzer, and this frequency counter is under $100. Now, it's not lab quality, so if you're looking lab quality, I suggest you go spend your money on something else and get better counter. But for the general hobbyist, and you don't need to immediately see the frequency, this is fine for doing some testing of different circuits and so forth when you're on the bench, doing things. So yeah, but I hooked the thing up and checked it out, and channel A 0 to 50 megahertz does not work. It just random counts. So I got on email and emailed my friend over at Banggood, and immediately he sent me a second unit, no questions asked. Now, you're talking about good service. Well, I didn't pay for the first one to start with. It didn't work. I told him I could try to fix it, but he sent ahead and sent me another one. And as you can see, we're at 30 megahertz, and it's pretty much a bang on frequency with no problem. It works like a charm on both channel A and channel B. So instead of doing just a plain review video, I figure we would turn this into a repair video and see if we can find out what has caused this counter to fail and not work on channel A. So that should be pretty fun. And if we can get this thing working, I'm going to take one of these counters and pass it on to one of you fine folks that leaves your comments down below. That's the best I can do for you. You know, free counter, so if you're interested in it, all you have to do is just comment. If you know, you comment and you don't really want it, and select you as the winner and you want to pass it on, just let me know if you're not in the need of a counter. So you know, to be fair, I'll have to use the list down below to pull from. So, you know, if you're not interested in it, let me know, or tell me who you'd like to pass it on to, and that's what we'll do. So what we're going to do now is go ahead and tear this thing down and see why this one does not work like that one. I mean, I'm really impressed on just how well that one is on frequency. Now, you know, my Rigol signal generator, which is the DSG815, is pretty new, so you know, I'm pretty sure it's spot on anyway, because it's still within the warranty and calibration. So with that, we'll get this thing tore down and see what we can find. Now, you know, another thing I liked about this counter is the size. But don't let the size fool you. You're not going to see a whole lot inside of this. It's more cased than it is anything. But you know, it's nice that they took something that was kind of simply built. You know, it's all microcontroller controlled anyway, and put it in a decent sized case so it matches your other stuff on the bench, and if you hook something you feel like you're not going to pull it off. And it's got a little weight to it. It's not bad at all, but a lot of it's due to this thick case that they use. So to get into this, we'll turn it over and we'll have to remove the screws in each one of these feet, and then we can pop the top off of it. Alright, let's go ahead and get the cover off. Put my jacket back on. It ain't quite warmed up in here this morning. It's 4 o'clock in the AM, and good chilly, 32 degrees this morning. Heat ain't quite kicked in good yet. Alright, go ahead and remove this ground wire into the top cover. Be careful when you do that, because there's a spring underneath of it, and that may go flying off in the wild blue yonder. And what they do, they just got a piece of it's like a aluminum foil that they stick onto the top, and then just ground it. I'll reposition the camera and we'll get a better look at this. So here you are looking at the inside of it. You can see mains plug, which has a real fuse in it. This is something you don't see in a lot of cheaper made stuff, is a fuse, but this does have a fuse in it. We got our power transformer. There's some power supply stuff going on over here. Some 74 series logic. We have a Atmel MCU, our crystal reference, and on our front board we have a looks like some type of a microchip PIC. Yeah, it is microchip. It's a CF775 that's probably controlling the some of the functions on the front panel, and probably the LEDs. So it's very simply built. It's not a whole lot to it. Here is our inputs for channel A and channel B, and you see it just simply it's getting this power here and then going back down to the board. So let's take a look at the schematic and see if we can see anything that maybe catch our eye on it. So we see when coming through our BNC connector, we go through a 0.01 capacitor, We got a couple of clamping diodes here to help protect the front end. Comes on through this IC13. I can't read what that is. A little bit too small. This may be a switch. Then it comes on down here through this transistor where it gets some amplification. Here. Then we see it comes right on down and goes into this IC here, which I cannot read the designator on it. But if we look back over here at channel B, you know, it's basically a mirrored image, but it has a few more amplifier stages in it. Just going through some logic over here and then over to the IC chip. So this means that the problem could be in this section, or it could be over here in this input front end. So I think we're going to go here to first and start checking on that. I think the easiest way, just go ahead and start by removing the front cover. Or the front panel. And as you can see, everything just comes unplugged. That makes it a lot easier to get to where we need it. We have some shielding here around the input board, and you notice, you see that one side of it is up. It's not clamped all the way down to the board, which is not also not soldered on the front edge. It's only soldered back here on the back. Let's go ahead and pull this import board out. I have to desolder these two terminals on each side here. I got the shield off, top and the bottom, and I'm already seeing something that's caught my attention right to start with. And if you look right back here in the back, you can see this resistor that's laying over. Well, it looks like it's supposed to be inside the shield, but it's actually laying outside the shield. So what I'm going to do is go ahead and desolder these BNC connectors and pull this board out, and we'll get a better look at it. Okay, so here's our front end board. Got it out. Had to desolder the BNC connectors and the grounds to get it out. It would have been a lot nicer if they would have had the BNC connectors with the bolts on the front, so you just loosen the bolt and pull it out. But that's the way it's designed. You know, you got to keep this thing down to a price anyway. And see this resistor right here that's laying over? Let me give you an idea of what's going on here. There you go. As you can see, the way this resistor is in there is completely shorting out on the case. Now the case grounds on these pads. You can see what's soldered back here on the back. They didn't solder the front. Probably because you just can't get to it with it in the front panel. So this looks like this is where the failure started at. And the way I see it, you know, this board is mounted in this front panel. So for them to put this cover on, they kind of got to stick it up in there and work it in between the board. And probably what they did when they got it up there, they pushed that resistor over and then clamped it down. A bit of a design flaw. I fell on the engineer's part designing this the way that they did. I can see where that would be a an issue at getting this cover on, because this thing is pretty tight when it's in this board up here on this front panel. So you ain't got a whole lot of room to work with. So getting that thing in there, that resistor was a little bit high, and I can see it right in my mind how it happened. They probably got it in there at this angle and just pushed that resistor right over like that, and then clamped it in. Now, one thing they could have done was use smaller leads instead of having the resistor stuck up that high. So we'll get it tested out and see what it does now with this resistor not shorted. Okay, well, I put it back together, you know, out of the box. I decided not to even show that part, but the counter still would not work on channel A. So I pulled the board back out, and I got in here and started looking, and the first thing I wanted to do was check these two clamping diodes. Come on, focus. Those two diodes right there. I've got one of them, well, both of them lifted up on the ground side. So we just want to go ahead and check those and see what we can find with it. That was definitely shorted. Okay, well, both of those diodes are shorted. That's interesting. I'm not sure how by shorting out this resistor that it popped these two diodes. I'm going to go ahead and get them out and get those changed, and then we'll see what we got. Okay, I got those two diodes replaced. Also removed these two resistors and pushed them on through the board and soldered them back in place and cut those leads off. Now we'll get this reinstalled and see if our counter will work. Okay, I got the single generator set at 10 megahertz and about 50 microvolts. We'll go in here and we'll set the counter to 2, and we'll confirm that one. And we'll do the same thing with this one. Just kind of sit down and set the programming range of these things for whatever frequency you're going to use with, you know, options 1, 2, and 3. Got the gate time set about halfway on both, so we ain't using all the resolution of the display to start with, and plus it comes up a little faster. I'll turn them both down just a little bit more. I'll enable the signal generator. And we can see this one is spot on 10.000, and the other one is at 9.9999. That one's just a little bit low, but we see this one is working now on channel A. If we turn our gate time up a little more, we can get a little more resolution. I'll turn this one up just a bit too. Go ahead and bring it way on up, and it'll take it a minute for it to populate the other. And there it goes. You see we're sitting at about a 3 on this one. That's about, 3 parts per million. The other one's at 9.99998. So it's very, very close also. So no problem whatsoever. The channel A is now working like it's supposed to. I see nothing wrong with it now. And like I say, we had about minus 13.01 dBm. Okay, I've let them sit here and run for about 30 minutes. And you see the one on the right is at 9.99999. And this one has a 3 on the end, so it should be fairly warmed up, stable. Take a ceramic device, go ahead and tweak this trimmer just a little bit. See if we can bring that 3 down closer to a 0. That's a 2. And there's 0. Might be just a little bit too far. Takes a minute for this thing to update. And she's spot on now. Well, there you go, guys. She's all back together. She's working good. It even has this pull out. You can use it for a handle if you're taking it somewhere. You can pull it out and you can adjust it how high you want it to set up. Not bad at all. Again, it's not a lab grade frequency counter. It's great for a hobbyist. They're cheap. Someone like say, okay, it came from China, we saw the problem that was wrong with it. This one works fine, no problem with it. I have bought brand new expensive test gear in the $1,000 ranges that has had factory defects before. So I'm not going to blame this on a quality problem just because it came from China. It can happen to anyone, especially when they put something together like this. I see stuff like this all the time, even in name brand stuff. So yeah, it is what it is. It's a cheap frequency counter. It's a high resolution counter. It works great for the most part. If you need a fast signal, just turn the gate time down and it'll come up quick on the display. If you need high resolution, you turn it back up. And 0.01 hertz to 2.4 gigahertz. So like I said, I'm gonna give this away to somebody. I'll pick someone randomly from the comments below. Again, if I pick you, if you don't want it, just tell me to pass. We'll pick someone else, or you can choose someone. It's all entirely up to you. Anyway, hope you enjoyed the little video. Big thumbs up for Banggood being spot on. Called them, told them I had a problem. Boom, they got me another one right in here very quickly. So it came in faster than what this one came in. So imagine that. But yeah, good on them. Standing behind the product. That's something. I don't care who it is. If you're selling the product, if you stand behind the product. Again, I bought neither one of them. Banggood sent it to me for a look at and review, and there was a problem. They sent me a second one. So there you go. Anyway, Okay, I'll put a link to this down below if you'd like to look at one, in case you decided, this might be something that you could use. So click on the Show More tab down below. Put a link to the website, Patreon, contact information down below in the Show More tab. Leave your comments down below, and we'll see you in the next video.